All right, strap yourselves in because today we're going deep, really deep, into a concept that'll twist your understanding of
Oh,
physics.
yeah, we're talking about the idea that those fundamental forces of the universe, the ones we all learned about back in school.
Gravity, electromagnetism, the whole gang.
Yeah, well, they might not actually be forces at all.
Whoa, okay, hold on, not forces, come on. I mean, I can feel gravity right now.
Exactly. You feel it, but what if, instead of it being this kind of fundamental law, it's more of a side effect
A side effect of what?
of something deeper, a deeper reality, a more fundamental reality that we're just beginning to grasp?
So instead of, gravity being the bedrock of the universe.
It's more like imagine ripples on the surface of a pond. Those ripples are the forces,
Okay, so gravity, electromagnetism, the strong and weak forces, they're like the ripples.
and the pond itself.
That's the deeper reality we don't quite see.
Right, it's the underlying framework where matter, energy, even information itself all interact.
Okay, so much to unpack here. Let's start with something familiar, gravity. I mean, it's keeping us both on the ground, but how can something that, keeps our feet planted firmly on the ground not be a real force?
I love that question because it forces us to really rethink what we think we know.
Right. It's like gravity, it's a given. Right.
Right, so think about it. We always picture gravity as this force pulling objects towards each other.
Like the bigger the object, the stronger the pull.
Exactly. But what if, and here's where things get really interesting, what if it's not a pull, but more of a push?
A push. That sounds kind of backwards.
It does, but stick with me.
Huh.
Imagine that matter, anything with mass, actually bends the fabric of space itself.
Bends it. How?
It's like, picture a bowling ball on a trampoline that creates a dip, right?
Yeah, the trampoline kind of sinks around the ball.
Exactly. And that's kind of what's happening with matter in space. It's warping the space around it.
Okay, so what we experience as gravity is just us following the curves of that warped space.
Precisely. It's not about being pulled towards the center. It's more like sliding down a slope in the fabric of space itself.
Wow, okay, that's a serious mind bend right there. So gravity isn't an actual force, it's just a consequence of warped space. I think I'm getting it, but how does this whole warped space idea, how does it apply to something like black holes?
Ah, black holes, those cosmic enigmas. Now, they're a perfect example of how this emergent perspective really shines.
Okay, but lay it on me.
We tend to think of black holes as these monstrous objects with, like, super strong gravity that just sucks everything in.
Yeah, like cosmic vacuum cleaners.
Right, but from this emergent view, it's not about a super strong pull. It's about the fabric of space itself being so warped, so intensely curved around the black hole.
So warped that nothing can escape.
Exactly. Imagine falling into a pit so deep, so steep, that you can't climb back out. That's more like what's happening with a black hole.
It's not being pulled in, it's like falling into a cosmic abyss.
More like sliding down an incredibly steep slope in the fabric of space itself. There's no escape once you cross that event horizon.
Okay, that makes my head spin, but I think I'm starting to get it. So gravity isn't pulling things in, it's more about the shape of space itself. That's wild.
It is wild, isn't it? And it really changes how we think about the universe at its most fundamental level.
So if matter warps space to create what we experience as gravity, what happens if there's no matter at all? Would there even be gravity in an empty universe?
Ah, you're really getting into the heart of it now. And that's the beauty of this emergent view. It allows us to ask these kinds of questions.
So what's the answer? In a totally empty universe, would there be gravity?
Well, according to this view, no. If the universe were completely empty, perfectly smooth with no matter to warp it, there wouldn't be any curves, no slopes in the fabric of space.
So no gravity.
Exactly. Gravity isn't an inherent property of the universe. It emerges because of the way matter is arranged, how it warps the space around it.
Wow, that is mind-blowing. So gravity, it's not what we thought it was, but what about the other forces, like electromagnetism, the force behind light, electricity, magnets? Do those fit into this whole emergent picture too?
Absolutely. And electromagnetism is where things get even more fascinating because it brings in the idea of balance, of the universe trying to find a kind of equilibrium.
Okay, now you've really got my attention. The universe trying to find balance. Tell me more.
All right, so let's ditch the idea of electromagnetism as a force acting between charged particles for a second.
Okay, doing it.
And instead, let's imagine it as the universe's way of balancing out energy.
Balancing energy. How?
At a very fundamental level, we have these things called quantum fields. Think of them as the underlying fabric of reality.
Okay, got it. Quantum fields, the fabric of reality. Go on.
And these fields, they can have Imbalances, asymmetries, kind of like having too many electrons in one spot and not enough in another.
So it's like a cosmic seesaw that's tilted too far to one side.
Exactly. And just like you'd want to even out a seesaw, the universe, it seeks to balance these asymmetries in its quantum field.
Okay, so the universe doesn't like things being out of whack.
You got it. It's constantly striving for balance, for equilibrium.
And how does it do that? How does it balance these energy imbalances?
That's where electromagnetism comes in.
Yeah.
It emerges as the mechanism, the tool for restoring that balance.
So electromagnetism, with its positive and negative charges, it's like the cosmic equalizer.
You could say that. It's the way the universe smooths out those energy bumps and dips.
Wow, so light and electricity, all those electromagnetic phenomena, they're just byproducts of the universe trying to stay balanced. That's a really different way of looking at things.
It is, but it's a perspective that opens up so many possibilities. It means that even something as fundamental as light, it wouldn't exist if there weren't these imbalances to correct in the first place.
So in a perfectly balanced universe, no asymmetries, no bumps or dips in those quantum fields, there would be no light. It'd be like a cosmic dark room.
Exactly. Light itself is a product of this cosmic balancing act.
That is incredible. It makes you wonder about the nature of light, of energy, of everything, really.
It does, doesn't it? And it shows how interconnected everything is in the universe.
Absolutely. But hold on, I have another question. How does this balancing act actually play out? Does the universe send out like little memos saying, hey, too many electrons over here, got to even things out?
That's where those little messengers come in, the ones that are constantly zipping around, carrying energy and information to restore that balance.
Messengers? Are we talking about like angels or something?
Not quite angels, but something just as amazing, photons. Think of photons as the couriers of electromagnetism.
Photons, as in light particles.
The very same. They're constantly being exchanged, absorbed, and emitted, carrying energy from one place to another.
So they're like tiny little energy packets making sure the cosmic scales are balanced.
That's a great way to put it. It's this constant dance, this intricate interplay of imbalances and corrections that gives rise to all the electromagnetic phenomena we see.
So photons are like tiny couriers, zipping around the universe, making sure everything stays in equilibrium.
You got it. They're the unsung heroes of electromagnetism, constantly working to keep the universe balanced.
It's amazing to think that something as familiar as light is actually a product of this cosmic balancing act, these tiny photons constantly zipping back and forth.
It really changes how you look at the universe, doesn't it?
It does. It makes you realize how much is happening behind the scenes at levels we don't usually even think about.
Exactly. And it's just the tip of the iceberg. There's so much more to explore when we start to view these forces as emergent properties.
This is blowing my mind. I'm starting to see the universe in a whole new light, literally.
It really is a whole new way of looking at things, isn't it? It's like we're seeing the universe with fresh eyes.
Yeah, it's like someone just flipped on the high-def switch in my brain.
That's a great way to put it.
So we've talked about gravity and electromagnetism, how they emerge from this deeper reality. But what about the other two forces, the strong and weak nuclear forces? Those always seemed, I don't know, a little more mysterious.
Oh, absolutely. They're the ones that govern the interactions within atoms themselves, deep down in the nucleus.
Yeah, the ones we can't really see or experience directly, but they're, holding everything together.
Exactly, and they fit right into this emergent picture, too.
Okay, so let's start with the strong force, the one that, glues quarks together to make protons and neutrons?
That's the one. The one that's responsible for the incredible energy locked up inside the atom.
Yeah, the one they say is 1,000,000 times stronger than gravity. It's hard to imagine that kind of strength not being like a fundamental force.
It is mind-boggling. But imagine this for a second. Instead of a force pulling things together, what if it was more about space itself, the fabric of space, resisting being stretched apart?
So instead of like super glue, it's more like a super strong elastic band holding those quarks together.
That's a great analogy. You've got it. At these incredibly small scales, the very structure of space might resist the separation of quarks, like it's trying to keep them close.
So the strong force isn't really an attraction between quarks, it's an emergent property of space itself.
Exactly. It arises from the way space behaves at those tiny, tiny distances.
That's incredible. So what happens if, hypothetically, we could stretch that space enough? Could we separate those quarks? And would the strong force just disappear?
Yeah, that's a question that pushes the boundaries of our current understanding. But from this emergent perspective, It's certainly a possibility.
So the strong force only exists because of those specific conditions of spatial confinement.
Exactly. Change those conditions and the force itself might vanish.
That's mind-blowing. Okay, so we've got gravity emerging from warp space, electromagnetism as a balancing act, and the strong force arising from spatial confinement. What about the weak force? Where does that one fit in?
Ah, the weak force, the one responsible for radioactive decay.
Yeah, that's always seemed kind of spooky to me. Particles just like spontaneously transforming into other particles.
It is a bit strange from our everyday perspective, but imagine this. Instead of a force causing that decay, what if it was more about the universe's tendency to move towards lower energy states? Like it's seeking a kind of equilibrium, a more relaxed state.
So it's like a ball rolling down a hill, naturally seeking the lowest point.
Precisely. Particles in high-energy states, they naturally transition to more stable, lower-energy configurations. It's about finding that balance, that sweet spot of stability.
So the weak force, it's not really a force, it's more like a natural flow, a tendency towards stability.
Exactly. It's about the universe finding its most comfortable state, its preferred arrangement.
The universe having preferences, that's an interesting thought.
It is, isn't it? And it all ties back to this idea that these forces, they're not fundamental. They emerge from these deeper principles governing how the universe behaves. It's less about rigid laws and more about tendencies, preferences, a cosmic drive towards balance and stability.
So if these forces are emergent, could they like change or even disappear under certain circumstances?
That's one of the most intriguing implications of this whole idea. Imagine, for instance, the early universe, just moments after the Big Bang.
Oh, wow, going way back. So everything's incredibly hot, dense, like a cosmic soup.
Exactly. And almost perfectly uniform, no stars, no planets, just this sea of energy.
And in this super symmetrical, high energy state, these emergent forces, they wouldn't exist.
That's the mind-blowing possibility. As the universe expanded and cooled, asymmetries began to emerge, those variations in energy and density that we talked about.
So the forces we experience today, they're not just emergent, they're also products of the universe's evolution, how it's changed over time.
That's right. It's like the universe itself had to go through this incredible transformation for these forces to even appear.
Wow, that really puts things in perspective. So does that mean there could be other forces out there, ones we haven't even encountered yet, just waiting for the right conditions to emerge?
Now there's a thought to ponder. Imagine places like black holes, where gravity is so intense, where the fabric of space is so distorted. What happens to these emergent forces in those extreme environments? Do they change? Do they vanish altogether?
Man, those are some big questions.
They are, and they're exactly the kind of questions that this new perspective invites us to ask.
I feel like we've only just scratched the surface here.
We have, and that's the beauty of it. This is just the beginning of exploring a whole new way of understanding the universe.
Yeah, it's a journey. I'm definitely ready to continue.
Welcome back. It feels like we've been through a cosmic boot camp for our brains.
I know, right? We've really stretched our understanding of how the universe works.
So we've tackled gravity, electromagnetism, the strong and weak forces. But there's one realm we haven't ventured into yet.
Oh, you mean the quantum realm?
The very one, the world of the super tiny where things get really, really weird.
Ah, yes, the quantum realm, where particles can be in multiple places at once, where uncertainty is the name of the game. It's a place where our everyday intuition about, well, pretty much everything breaks down.
And that includes our understanding of forces.
So how do these emergent forces we've been talking about, how do they play out in this strange quantum world?
That's where things get even more mind-bending. In the quantum realm, forget about those fixed forces acting in predictable ways.
Okay, no more neat and tidy forces.
Instead, picture this constant dynamic dance of particles. They're popping in and out of existence. They're entangling and disentangling. Their relationships are constantly shifting. It's a kaleidoscope of possibilities.
So it's less about rigid laws and more about tendencies and probabilities.
Exactly. And in this quantum dance, forces wouldn't be these constant, unwavering entities, but rather fleeting patterns, emerging and dissolving as particles interact.
So in a way, the forces we observe on a larger scale, like gravity holding us to the Earth, those are like an average of all this quantum craziness happening beneath the surface.
Think of it like a giant pointillist painting. Up close, you see all these individual dots of color, seemingly random and chaotic.
But when you step back,
those dots blend together to create a coherent image.
So the forces we perceive are like the image, and the quantum interactions are the individual dots. I like that.
And just as the image in a pointillist painting can change depending on your perspective, The nature of these emergent forces might also vary depending on the scale at which we observe them.
It really makes you realize that the universe is far more nuanced, more interconnected than we often give it credit for.
It challenges us to rethink our assumptions about what's fundamental and to appreciate the intricate dance of matter, energy, and information that gives rise to the reality we experience.
It's been a wild ride, and I have to admit, I'm walking away with more questions than answers, but I guess that's the sign of a truly great deep dive.
Absolutely. It's about sparking that curiosity, pushing the boundaries of our understanding, and embracing those mysteries that still lie out there in the universe.
So, to all our listeners out there, we leave you with this final thought. If forces are emergent and conditional, if reality itself is this incredible tapestry woven from the dynamic interplay of matter, energy, and information, what does that say about our place in the universe? What possibilities does it open up for us to understand and interact with, and perhaps even shape the very fabric of existence? Keep pondering, keep questioning, and keep exploring the depths of this remarkable cosmos we call home.